Okay, well, it's lovely to see everybody as always. Hope everybody's been doing well, and apologies and thank you for people accommodating moving the session back a week from last week. Unfortunately, it just conflicted with the organizing meeting for the ACDNU. That might continue to be a problem in the future. I have to look at the dates and see if we need to make some adjustments to either this meeting or the organizer meeting. Larry was going to adjust the organizer meeting and then forgot. So it seemed easier to change our journal club than have him do a last minute shift. So we'll see what happens for the next one. So stay tuned for that. Okay, so two review articles today. I think they are both really nice reviews that I think Scott did a really great job in this first article that we'll discuss, really pulling in very concise manner the results from a number of experimental studies, mostly in dogs, that have shown a lot of what we understand to be true in our patients with kidney disease. And then the other manuscript really is kind of I think, a good just kind of overall take-home summary of what we've been discussing, the intact nephron hypothesis, the trade-off scenario. It kind of just puts it all together, which hopefully will be a nice kind of finishing statement on kind of this initial section of the pathophysiology of any type of renal injury. So why don't we start talking about the first article, the veterinary one that Scott Brown summarized on renal pathology, pathophysiology, lessons from the canine remnant kidney model. And we'll open it up. Just any questions or areas that people thought were interesting or confusing that they'd like to start talking about. Excellent, excellent. uh, I, I have a hard time with all the animal models. I recognize that we've learned a lot from them, but man, have we ripped a lot of kidneys out of dogs and cats and clearly mice and rats and everything like that. And I hope we know enough, and modeling has reached such an advanced state that we just don't have to continue such processes from an ethical standpoint. But I recognize what those animals certainly gave us in terms of our understanding of progressive kidney disease, and am appreciative for that. Yeah, I guess I can start. I think what I thought was really interesting is that a lot of this that's been done, and I think and anyone can correct me if they have other information, but I think Scott was really probably one of the most productive veterinary uh, practitioners that was doing micropuncture studies. I know other people have done it. Larry did it as part of his PhD program, but that was in rats, I believe. And I know other people have worked with Scott Brown a long time in various stages of their career, but I think Scott really has the most experience out of everybody, and it's his information and then some of the authors that he cite that we've even read some of their manuscripts. We've read one of the papers by Bricker earlier. These are some big names in renal physiology, and a lot was learned from dogs undergoing this unilateral nephrectomy and then some portion of a cauterization or ablation of their remnant kidney. So there, even human physiology has a lot to thank dogs for, and certainly rats and mice have been there along the way too, but their kidneys are smaller and they don't respond the same way. Ablation tends to cause a lot of inflammation versus just ligating vessels. So dogs have been models that have really led to these same concepts being ingrained in human nephrology just like they are in veterinary nephrology. So dogs have really kind of paved the way, and there have been studies that have been done in cats as well too. And to my knowledge, I don't think any are strikingly different, but I can't say that I recall enough of them off the top of my head to say this is something that was shown in dogs, but this was not shown in cats whatsoever. But this review article is specifically just in canine models, so those cat studies are really not discussed at all in here. But I think what we've discussed have just been shown here, and this is kind of maybe going backwards, that we've looked at some review articles that have gone through some of these data and shown their conclusions. And again, here those studies are presented, and little bits of the puzzle are presented again. So I liked how Scott organized this, basically saying, what have we learned, and then a specific topic, and gave the meat of it, the results of those studies. Didn't really get into a lot of the specifics, and that would be far too much in order to do, but then would go on to pose another area in renal pathophysiology, and then the studies that were then created from it. So I thought it was really well organized, and certainly really helpful to identify those areas that if we're trying to figure out what the experimental models might look at, you can kind of go back to that subheading that might be applicable to it, which was really cool. And I thought that it was interesting that the canine remnant model was really the first time that was documented that renal disease is progressive, that there were kind of differing schools of thought, that some individuals thought that depending on the origin of the injury, that you might have some static loss of function, or you're left with whatever nephrons are there and they're going to remain normal. And that was very different than the intact nephron hypothesis, which has been shown to be the prevailing mechanism of renal compensation. And using a canine model, that showed that yes, the progressive loss of nephrons and the subsequent compensatory changes will cause these abnormal consequences that will result in further nephron loss, and then that cycle just continues. So one of the huge ideas that chronic kidney disease is progressive was actually demonstrated through some of these canine models, which is kind of surprising that that was debatable in just the realm of human medicine before we had these models to show it. A lot that was discussed, I thought, was pretty similar to what we've gone over. The mechanisms of glomerular hypertension, hyperfiltration, the enlargement of those cells resulting in the single nephron GFR increasing to be able to excrete that total solute load, was again something that we've discussed, but I am certainly always happy to see it again, because it is something that I can just sneak out of my brain if I don't read it every 6 months or so. Okay. Let me pause there if there are any other thoughts or questions before we get a little bit deeper. I'm just going to